Hey friends, this is YMST Sastri. Now I am going to give a lecture on estimation, specifications and contracts. Welcome friends. In last video we have seen rate analysis. There we have calculated the cost of the labor, the cost of the material at the working site. Okay, so here in this video we can calculate the earthwork, which is most important one. Okay, so in generally all the civil engineering projects like roads, railways, earthworks, earthen dams, canal burns, buildings, etc. involves the earthwork. This earthwork may be either earthwork excavation or earth filling. Both are possible. Sometimes both are also possible, and the desired shape at desired level. Basically, the volume of the earthwork is computed from length, breadth and depth. We need length, breadth and the depth to calculate the volume of the earthwork or earth filling. Okay, so here in this video we have seen, we will see different types of earthwork calculations. Okay, so here earthwork calculations for either roads or canals can be calculated here. We can calculate both roads or canals can be calculated. Okay, so here in calculation two cases are there. So case 1, coming to the case 1, the volume of the earthwork. Work in either banking or in cutting, having no longitudinal slope, means at starting and at the end you can find the same height. Okay, you can find the same height. There is no slope variation along the length means longitudinal section. And case 2, coming to the case 2, there is having a longitudinal slope, means having some gradient in either rising or falling. Okay, rising gradient or falling gradient. There is a possibility of both rising gradient and falling gradient, that is along the longitudinal slope. Okay, so two cases are available. One is without slope and another one is with slope. Okay, so if it is with slope, then the structure may like this. Suppose if we consider an embankment, it may like this. Sorry, I am somewhat not good to draw the diagrams. Okay, so here the depth D in both sides are equal. Side slopes, say n is to 1. Here also you can find some n is to 1. The formation width is B. Okay, formation width is B. Similarly, in case of a cutting also you can find the same. In case of a cutting also you can find the similar way. It may look like this. So here also same depth D you can find. Okay, so this is with case 1. In case of case 2, here you can find different depths. Here you can find one depth and here you can find another depth. The formation levels are different. Formation levels are same or different. So Along the longitudinal section you can find some slope. You can find the slope either in rising or either in falling. In general, you can find a shape like this for either embankment or for cutting. Okay, so here a trapezium, we need to find the area of the trapezium, then it is multiplied with the longitudinal length. It is multiplied with the longitudinal length, so you can get the volume. Okay, so how did we calculate the area of this trapezium? So first we can divide the trapezium into two parts. One is with triangle and another one is with a rectangle. Okay, here the top width you can find with B. This is also called as a formation width, and this is depth D. Okay, side slopes are n is to 1. Side slopes are n is to 1. Then area of triangle portion is B into D. Okay, then area of the rectangle portion, and area of the rectangle portion is B into D. Area of the triangle portion is, this is n into D. So it is looks like a rectangle triangle. So half into n into D into height D. So n into D into D square, that is half n D square. Okay, so like this we have two triangles, two similar triangles. Now total area is equal to BD plus two triangles, 2 into half into n into D square. So 2 both are gets cancelled. BD plus ND square is the total area. BD plus ND square is the total area of the rectangle. This is trapezium. Then the total volume is equal to BD plus ND square into L. This is for case 1. This is for case 1 where the depth D is same. Depth D is same. For case 2, we have different methods to calculate the length. Generally, we have 4 methods are available. They are mid-ordinate or average depth rule, mid-ordinate or average depth rule, that is equal to D1 plus D2 by 2. So we have two depths at two ends. One is D1 and another one is D2. So we are taking the average depth D1 plus D2 by 2. Okay, then you can find D mean. So area equal to B into dm plus n dm square. This is mid-ordinate. And then length, volume equal to bdm plus n dm square into L. Okay, so second rule, midsection. Okay, second rule is midsection. There we have to take A1 and A2. Then we can take the average of AM, that is A1 plus A2 by 2. Then the AM is multiplied, and then AM is multiplied with L. Okay, next third one, a popular rule, that is trapezoidal formula. trapezoidal formula. And fourth one, that is also popular, Simpson rule, or also called as here prismoidal formula, prismoidal rule. Okay, so by using Simpson rule and prismoidal rule, we can find the volume. So trapezoidal rule. So if it is a trapezoidal rule, then trapezoidal rule, in case of a trapezoidal rule, volume equal to L by 2 into A1 plus AN plus 2 into A2 plus A3 plus up to AN minus 1. If it is a Simpson rule, volume equal to L by 3 into A1 plus AN plus 4 into A2 plus A4 plus A6 plus up to AN minus 1 plus 2 into A3 plus A5 plus up to AN minus 2. Okay, so here we need to consider one thing in case of a Simpson rule. If we have taken area with A1, then we have to apply this one. If we have to consider with A0, then the formula is different, somewhat different. L by 3 plus 4 into A3 plus A3 plus A5 plus like that, and 2 into A2 plus A4 plus A6 plus etc etc. It will change like this. Okay, then there is a slight change. In case of instead of 4 we have to use 2, instead of 2 we need to use 4. That's it. Okay, so we can solve one small problem. Find the volume of earthwork in an embankment of a length 12 meters, top width 5.5 meters and depth 2.5 meters. Okay, side slopes are given with 1.5:1. Okay, so once the problem is given like this, then it is very important to draw the diagram first. Okay, so top width is 5.5 meters, that means B is given as 5.5 meters. Depth of cutting or depth of embankment is given as 2.5 meters. 2.5 meters. Side slopes are 1.5:1. 1.5:1. Side slopes are given as 1.5:1. Okay, so then we can calculate the earthwork, right? So top width is given as B, which is 5.5 meters. Next, depth D is 2.5 meters. Then side slopes 1.5:1. Okay, 1.5:1. Then volume, a simple formula, volume V equal to B into D plus ND square into the given length L. How much? L equal to, L is given as 12 meters. Okay, I think we have not written that. Length is 12 meters. Then calculate. So 12 into B 5.5 into D 2.5. This is related to case 1. Okay, so both sides are with same depth. Both sides are with same depth. So 2.5 plus n value, this is 1.5, 1.5 means 1.5 into D 2.5 whole square. Okay, so calculate it. When you calculate this, you can find the required answer. So 5.5 multiplied by 2.5, which is 13.75 plus 2.5 whole square into 1.5, 9.375 multiplied by 12. So 9.375 plus 13.75 multiplied by 12. How much? 277.5 meter cubes. 277.5 meter cubes. So here we need to write the units. Very much important. Need to write units. Okay. Right? So we can see in next lecture.